Okay, so on Sunday we are going to be in the computer lab, back downstairs again, and the project is due on Sunday at 11 o'clock, print out, paper only. And then homework 11, which I distributed last time and is also posted on iLearn, that will be due on Thursday the 21st. Today we're continuing to talk about decisions related to how long should we keep equipment. And today we're going to look at the next step is comparing alternatives. Last time it was just you have a piece of equipment, how long should you own it? But today we're going to be looking more specifically at option A versus option B and the decision logic for how to do that. Any questions on the scheduling related announcements before we move on? All right. Well, this is a picture of a chemical plant. On the left, it looks very outdated. This is a picture of what a chemical plant probably looked like in the 1960s or the 1970s. And I'm sure this equipment was very expensive in its time. But the question should be not, does it look fancy or, is it sophisticated in appearance? But the question is, how well is it working? And what's the economics of the equipment that you own? So the objective for any company when it comes to the equipment is to minimize costs. Because actually, it's very rare that the equipment itself is making money. It's the application of the equipment that's making money. I mean, if the equipment itself is making money, that probably means that you're counterfeiting, right? But aside from that, the equipment is just used to perform a task that somehow is generating income. And so what you want to do is find the equipment that can generate that task as cheaply as possible. So we're going to be comparing the old equipment that we usually already own. That would be our Defender, is the existing equipment. And then the Challenger is some new proposal. You'll have equipment vendors wanting to see you almost every day when you get into the real world, people who are trying to sell you something. And so they'll be making a proposal, and what we're going to assume today for our calculation purposes is that both the Defender and the Challenger have an acceptable level of quality. They meet whatever required specifications exist. So they're able to produce the product in a way that is acceptable. Now, usually they'll have different service lives. The equipment that you already own has been used and it's starting to wear out a little bit. Maybe it can last for some more time, but it's not going to last as long as the new equipment. And so we have to use techniques to account for the different number of years that the equipment is going to last. And we'll talk about two different analysis types today. The first of them is when you don't have a study period specified. It's just that you know you're going to need to keep the equipment to do the task, but you don't know how long you're going to have to do the job. So an example of that is if you're in the manufacturing business, you can just assume that you're going to stay in the manufacturing business if no study period is specified. So you have to do an economic service life analysis. So think back to last class period when we were working with Excel. What were those different columns? What were you doing? What was our final objective during the economic service life analysis? What were you trying to find out? Annual worth, exactly, of what? There was different components of the cost. Okay, market value was one of the things. If you sell the item at a certain year, you can resell it. What was the other thing that went along with market value into capital recovery? Capital recovery accounts for the market value, which is the sales price once you dispose of the item. But what's the beginning point? It's the initial cost. It's when you first buy the item. So you'll remember that one of those columns from last time, we were doing the payment function, and it had both a future worth and a present worth because we were putting the initial purchase price into the present worth and then putting the market value for a certain year into the future worth. And then it was telling you what's the annual capital recovery. So capital recovery was one of the expenses we were dealing with last time, and then the other was the annual operating costs. And if we just go back to the figure we saw, our objective was to find this point. the point at which the total annual worth of the costs is the lowest. So you do that same thing when you're comparing alternatives. You do an economic service life analysis for both pieces of equipment, the Defender and the Challenger, and then you pick the one that has the lowest total annual worth of costs. So not just the equipment that you already own, but you find the lowest between the two alternatives and how many years it was. So let me give you an illustration of that. Because I knew we'd be spending some time talking about the project today, I did the first part of the in-class exercise and printed out the solution to it so we can just look at it. And then we're going to do the second half of the in-class exercise through the calculations. There you go. So the study period is not specified in this first example. Everybody have a copy? Okay, let's take a look at this first one. I may not have the solution of this one out. All right, in this first example, what we're looking at is a situation where the study period is not specified. We don't necessarily know yet that we're only going to be in business for a certain length of time. We just need to find out what's going to be the cheapest alternative for however many years it turns out to be, and then we'll worry about replacing the equipment when that time comes around that we find that we need to replace it. Okay, so in this instance, it's saying that the company is trying to decide whether to replace a robotic system. The existing equipment that we already own, that being the Defender, has a current market value of $15,000 and it declines 20% each year for 3 years. That's called depreciation, when the value of your equipment goes down by a certain percentage. So what we need to do is, that's going to tell us our market value. So the market value of the equipment next year is going to be 80% of what it is this year, and then the year after that it would be 80% of the prior year. The operating costs are $20,000 for the first year, $8,000, and then $12,000. So the operating costs, it looks like they have some variables here. That might include some refurbishment or service fees, but it's laid out for us. The Challenger costs $50,000, has a service life of 6 years before it wears out, and then the market value goes down 20% each year. We have the operating costs here. So what should the company do? What I've given you there on your printout is this solution. So what we did last time was we had these columns where we had the first cost, an interest rate specified. The market value is declining based on the information that's given. It's told that the market value goes down 20% each year. So that's this column B. The operating costs were specified in the problem statement. Now, column D, what we're trying to do is find the present value in year 0 of the operating costs for all of the years that we own the item. So for the first row, it's just the present value of this $20,000 that's paid at the end of year 1, taken to year 0. $24,000 is the NPV function of $20,000 and $8,000. So it's $20,000 in year 1, $8,000 in year 2, and we take both of those amounts to year 0. That's what the $24,000 accounts for. Column E is where we've now taken the present value of the operating costs to an average annual basis, spreading it out. So column E is different from column C because we're trying to find out every year how much it's going to cost you. So let's take, for example, if you own the item for 3 years. Your operating costs, the actual operating costs, if you keep it for 3 years, is that in year 1 you pay 20, in year 2 you pay 8, in year 3 you pay 12. But if you spread that out so that it's the same amount every year for 3 years, then that same amount you would have to pay would be the $13,595. So that's the annualized version. It varies a lot in reality, but we need to know the annualized version so we can calculate this final column, which is the total annual worth of the costs. So just by looking at it, you can see I've got a star next to the one that is the lowest total annual worth. And so if we keep the Defender, we should keep it for 3 years. But we also have to consider the Challenger. We've done the same thing to the Challenger, just laid out the market values that are specified in the problem statement, the operating costs that's specified in the problem statement, and then the same calculations. What you'll notice is that the cheapest alternative for the Challenger is $19,000 compared to $17,000 for the Defender. And so the answer is, what should we do? We should keep the Defender for 3 years. And at the end of those 3 years, then we have to go get bids, get quotations, find out what's best at this point, and do a completely new analysis. But faced with these two options, Defender or Challenger, we should keep the Defender for 3 years. So we did that same procedure last time in class. I didn't want to repeat it again. Any questions about this? The concept of it? Yeah. Year 1, the Challenger? The operating costs are lower, yes. Is that what you mean? The total annual worth, $20,000, if we just keep the item only for 1 year. So $20,000 is more expensive than this $19,000. The $19,123 is the cheapest if we were going to go with the Challenger, but we don't do that because the total, the lowest out of all of them is the Defender for 3 years. The cheapest out of all of them, yeah, out of both alternatives.
This lasts for 4 years. This lasts for 4 years.
Excuse me?
This will be 4 years. This will be 3 years.
This is 6 years.
No, I mean,
Okay. So you're saying, well, it lasts longer. Why not go for the one that lasts longer, right? This already takes that into account, the service life of it. It doesn't matter that it's a shorter number of years. Since it's cheaper on an annual worth basis, that means that at the end of the 3 years, you're still better off buying a new item then than you would have to buy the Challenger now. Yeah. And so just to reiterate, she pointed out that the cheapest for the Defender is 3 years of service, and the cheapest of the Challenger is 4 years of service. But you don't need to worry about that maybe the Challenger was longer, so is it better? The annual worth method already takes into account how long the equipment is going to last, and so all you need to do is identify the cheapest alternative among the annual worths. All right. Now, there's a note on the slide here. In the real world, our first analysis that we just did tells us we should keep the item for 3 years, right? You shouldn't wait until the end of that 3-year period to review the decision. Maybe someone's going to come out with new equipment that's even cheaper. It's just this year the Challenger costs $50,000. What if suddenly there's a promotion and now the Challenger is cheaper next year? Or what if the Defender suddenly breaks down and its operating costs have gone up much more than expected? All of these were just projections, right? The projection of the market value, the projection of the operating costs. We're trying to predict the future, and we're not very good at that. People aren't very good at predicting the future when it comes to quantitative things like this. And so the point that this slide is making is that it's okay for us to make a decision this year based on our estimates of what will happen in the future, but you need to review 1 year later, do a follow-up study to make sure that the Defender is still the best choice. put in any new updated values of expenses, prices, market values, and revisit the decision. All right. So that first one was when there's no study period specified. In the case of when a study period is specified, what that means is that we have to have the equipment in service for the same amount of time. That we maybe have a job that we know is going to last a certain length of time. If you're building a tower and you know it will take you 3 years to build the tower, then that would be an example of when a study period is specified at the beginning. So the process here is you make a cash flow diagram for both of them, and the study period where you're trying to figure out which is better, sometimes the study period is the life of the challenger. That's how you decide what to make for the study period. Now, if the challenger is lasting longer than the defender, we've talked about before different ways to handle that. One is contract services. One is to sell the longer item early. So early termination contract services. In today's example, what we're going to be looking at is a case where the equipment is being transferred to another division. So let's look at part 2 here. The study period is specified. There's an aircraft navigation system that is being proposed. The cost of the Challenger is $750,000 now, and then annual operating costs of $50,000 each year for 10 years. And at the end of the 10 years, it has no market value. So you can see that I have made a cash flow diagram of the Challenger, and you've got that on your paper there. It's on the flip side of the paper. The Defender, the existing system, has a present market value of $70,000, and it can be used for 3 more years, and the operating costs will be $30,000 each of those 3 years. And then at the end of the 3rd year, we have to do something because the study period here is 10 years. So what we're going to do is we're going to purchase a system at the end of the 3rd year that has an initial cost of $900,000. Here's where it gets complicated. Is that equipment that we're going to buy has a 10-year life in addition to the 3 years that we've already had by keeping the Defender. So the cash flow diagram extends beyond the study period. So you'll notice our Defender starts off with the $70,000 market value. It's the existing value of the equipment. Then our $30,000 operating cost. And then what we have to do is look at the new equipment. It has a certain capital recovery that's going to need to be spread out over 10 years because that is how long it lasts. But only 7 of those 10 years are included in our study period. After the 10 years, you're going to transfer the equipment into another project. And so you're only responsible for the capital recovery equivalent of 7 years. And on the cash flow diagram I've provided, that's illustrated for you. Those dashed arrows, that means it's the capital recovery that goes to another project. All right, so what I'd like you to do is go through these steps A, B, and C. The first thing, find the annual worth of the Challenger. Now, the table lookup factors are on the 3rd page. So we're going to do this the old-fashioned way. Table lookup factors. Find the annual worth of the Challenger, then the annual worth of the Defender. And the annual worth of Defender has a couple of different pieces to it because you're going to need, if we look at the cash flow diagram, you have to take the the Defender. You have to take the $70,000 and turn that into an A. The $30,000 that you see there on the paper, you need to take that to the present and then take it from the present out over A, 10 years. All right, then there's the annual operating costs of $50,000. You see that $50,000 amount? Well, it's right now in years 4 through 10. So you need to take it from 4 through 10 to year 3, from 3 to 0, and then from 0 to 10. And then finally, you need to calculate the capital recovery equivalent of the 900,000. So that's like a single purchase in year 3. So you're spreading that out over 10 years, but then only 7 of the 10 years are included. So I'll leave you to think through that. I've got the solution. I'll be circulating around and answering questions as you're working on it, and then we'll look at the answer in just a few minutes. This is one of those days where I wish we had a little more time. But I think the main thing I'd like you to take away from it isn't necessarily crunching all the numbers, but just like seeing the steps. You know, like if you can map out the logic of the solution in your mind, then you can eventually go through and look up the factors and punch the numbers into the calculator. Basically, just to summarize, what we're trying to do is find the annual worth over 10 years for both options. In the case of the Challenger, it's going to be easy because there's just the purchase price and the annual operating costs. And so on an annual basis, it's $172,000 of cost. The Defender's more complicated because we're keeping our old equipment for a couple of years and then we're going to buy the new equipment, but it lasts for 10 and we only need 7 of those 10. So we're transferring the equipment to another division, so they're going to take those expenses for the last 3 years, and we're only stuck with the 7 years of expenses that we need. So finding those 4 components together, then that leads us to the answer is it's $140,000 if we keep the Defender and then replace it. So it's much cheaper. The Defender option is best. So I apologize that we don't have more time to go through all the calculations. If you want to finish that up, then you can refer to the video. It'll be posted online. So over the weekend, I'll do my best to check email, but I'm planning to go out to the desert, and I don't get the best reception out there. So if it takes a couple of hours for me to get back to you, just know that it's because I'm sweltering in the heat. So I'll see you on Sunday.